talk about wait, being recorded by the host or encoded. Okay. So let's talk about the basic terms of the statics. Okay. So first thing is we should know about the mean. What is the mean of list of a numbers? Okay, what is the mean? Let's say we have few numbers like list of number. Let's say I would say like mm, a is equals to c. Like I am writing in the style of r, so we can uh, better understand the r as well. So let's say it is 1 2 4 7 3 and 14 like 20, right? So let's say we have this one. So how you will calculate the mean value? Mean. Mean will be sum of all the numbers I is equals to 1 to n divide, right? We have to submit it and divide it by n. Let's say this one is not n, this one is x. This is the summation. Sum of all the numbers from 1 to n divided by n. Or we can say that 2 plus 4 plus 7 plus 3 plus 14 plus 20 divided by 1, 2, 3, 4, 5, 6 values. So what will be the mean? Can anyone tell me the mean? What will be the mean? Can anyone tell me, please? Okay, no one? 8.33. 8.33. Okay, let's say I have an other list of numbers. Let's say whenever I say list or a vector, so it's the same thing, right? So let's say I have another vector b. It is noted by maybe in R we write in other way. Let's say in R we write like this one, right? Okay, we write in this way. Let's say b is equals to let's say c, list of numbers 1 1 3 3 3 7 2 7, let's say 9, right? This one. So if I ask you what is the mean, so in mean you will add this one divided by total number. So if I ask you what is the median, can anyone tell me what is the median in this one? Can anyone please tell me? 3. Why the 3? Median mean the middle values. So we will leave this one from the center. The centered value will be your median. So it will be 3. So if I ask about mode, what is the mode? Mode will be 3 as well, right? So median, we already know now mean, median, and mode. What are these 3 values, right? Okay, let's move on to another concept. Let's say we have, like, let's say, let me draw the line. Let's say I draw a line like this line, okay, and maybe this one is my center line, right? Like this way. Okay, so for example, I have the points. I have points like, for example, I would say I have points in here. Hmm, Points. Not like this. Okay. Okay. So I will draw. Just give me 1 minute. Okay. So for example, I have points over here. Let's say this one, this one. Let's say this one, this one, this one, this one. Right? So if I want to know how these points are distributed, distributed, these points are distributed. So we have to know about the concept of standard deviation or variance. Okay, standard deviation is noted as sigma, or variance, it is noted by sigma squared. We will just get the value of sigma squared, take its square root, we will find the standard deviation. So what variance tell us? Variance tell us how our data points are distributed um, among the mean point from the center of the mean. So for example, I have two numbers, let's say 1 and 9. These are two numbers. And I have numbers, let's say 4 and 6. These are two different numbers. Okay, what will be the mean in here? What will be the value of mean in here? Can anyone tell me what will be the value of mean in here? Okay, you guys. Okay, I will I will show you one thing. Oh, 2 is the mean. Oh, the one who said 2. Okay. Okay, students, I will tell you one. I will show you one thing first. Stop sharing, and I will show you my R. Okay, and where is the Zoom here? And share screen. You guys can see this my screen, the RStudio screen, right? Okay, so RStudio. So students, you know, whenever we end the class, after that I analyze our chat as well. So okay, for example, let's say this was the numerical method. Okay, I will read one chat. I save all of the chat in this one. Let me show you the list of chat. Okay, I will run this one and these files. Okay, so I have 9 meetings. Okay, so for example, we have a meeting on 23. This is in February, and then March, and in April. Now it is in May, right? We have this meeting. So for example, I want to analyze our meeting, that when student have their attendance, when the students write his roll number, when the student respond my question. So it will analyze everything. Okay, now let me show you everything. So what I will do, I made one R code. I will run it, and and finally it will give me a result. Now here you go, result. Now you guys can see the screen, right? Okay, so in here, you can see that I will get everything in here. that the student, maybe Katrina, she's the first, she came into the class, like she sent me the chat box, the roll number and chat, everything. You can see here. You can see everything here, right? So even when I ask any question or anything, like for example, maybe I ask some question, so you guys answer me. So I will analyze the thing that, okay, this guy, this guy, this guy, this guy answer me during the class. So I will give him or her a bonus marks. See, these students will get more marks. They will get the bonus marks as well, right? So just wanted to tell you that when I ask you one question, any question, please be responsive. Don't be silent anymore. Okay. So it's for you. The students who will be more responsive in the class, they will get good marks as well. They will get the bonus marks. Okay, is that clear to everyone? Okay, so now let's go back to our class again. I will share the whiteboard, right? Okay, now you guys can see the whiteboard, right? You guys can see the whiteboard or okay, whiteboard. Okay. Okay, let's go back in here and let's talk about again the covariance and the variance thing. Okay. Okay. So let's say I have the points 1 and 9, and I have a point 4 and 6. What are the mean value in this one? In here, the mean value is 5. In here, mean value is 5, right? But the thing is, in this one and this one is that how my points are distributed from the center, right? If I draw this one, let's say if I draw this one, let's say, let me remove our raise this one. Let's raise this one, okay? And then I will draw another line like this one, okay? And let's say my 5 is somewhere here. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's say these are 10 points, starting from 0 to this one. Okay, so my mean is 1, 2, 3, 4, 5. This point is my mean value in here. This is my mean value. And my one point is this one, and the other point is 9, this in here, right? Now, from here, you can see that from the mean, my points are very at long distance from this one. But in the other case, one point was 4, 1, 2, 3, this one 4 and 6. Again, the mean was this one. Now my point is not that much, is not have much distance from the mean, right? So these tell you the variance, that how my data points are distributed from the center point. From the center point mean from the mean value. Okay, this thing or the standard deviation, it tells you the deviation from the mean point. Okay, so for example, not only in x direction, what if I say this is in y direction as well? Let's say I have 1, 2, 3, 4, 5, right? So I have maybe some point in here, some point in here, maybe some point somewhere, maybe let's say in here, or in here, right? Now, from the mean point, mean of y, we will take a mean from the y point, and then we will check, let's say this line is a mean. So we will check from the mean point how my data is distributed. Okay. So if we take the distribution along x plus along y, not plus, just comma, this one is known as covariance. Okay, so this one is, if the variance, the formula of variance is given by variance of x. Let me clean it and write it in a neat form. Okay. Okay, so my variance is denoted by sigma square and is given by 1 over n minus 1 sigma summation of I is equals to 1 to n xi minus x bar squared. This is my variance, right? Where xi is a particular number, x bar is mean value, right? This is my variance. If I take the derivative of, the square root of the sigma square, it will be my standard deviation is equals to sigma, which is noted by sigma. Okay, so this one will be my. And if you want to talk about the covariance, what is the covariance? Covariance will be equals to covariance 1 over n minus 1 sigma I is equals to 1 to n x minus x bar mean xi square into y minus y bar square. This one will be your covariance. Is it clear? The concept is that you should know what is mean, what is median, what is mode, what is the variance, what is the standard deviation, what is the covariance. Okay. Mean, median, mode. Mean is the average, and mode is the more repeated value. Median is the centered value, and variance tell us the how my data is distributed from the mean point, and the standard deviation is also same thing, but it is a square root of the variance. And the covariance, in covariance we take the impact of from the x direction and the y direction as well. Okay, so it is 2D. I hope this thing is clear. Do you guys have any question regarding this one? Any question? Okay. So at any point you guys have question, please let me know. Okay, so let's go and talk about another property which is called skewness. Skewness. Skewness also tell us about the data distribution. So for example, let me try to draw a line. Let's say this one, and then Oh, okay, another one. Okay, let's say this is my figure A. I have a graph like this one. So, okay, let's see. Okay, let's say this is the center. Let's say this is the center. So I can say that my data is distributed equally. So I will say this one is a symmetrical distribution, right? This is known as symmetrical distribution. In here, the mean will be equals to median is equals to mod. Okay, so we also call it normal distribution. Maybe it's SY double M symmetrical. Okay, so we can also call it the symmetrical distribution or normal distribution. Okay, so let's make a concept of what is the normal distribution or what is a symmetrical distribution. Let's take an example. Okay, for example, I gave you a quiz. I gave you a quiz. So this is my, let's say, this is in my marks distribution. Let's say this is 0 point, and this is, let's say, 100 marks. Okay, this, and in here, these are the number of students in this direction, the frequency of the students, right? So let's say frequency of the students, right? We can say this one, or okay, so I would not say this one. Let's say we will distribute in other direction. Just give me, this is not this one. Okay, in here, let's say this is 0 and this is, let's say, 100. These are marks. Okay, and this is the, let's say, number of students. These are number of students. So you will see that most of the students, they are getting, like, maybe they are getting marks like between like 50, because it is symmetrical, so it will be somewhere here. Okay, this one here. Okay, so most of the student, they lie in this one, right? And maybe there are few students only, they will get the 100 marks, and maybe few students, they will get like the F grade, right? But most of the students, they will lie within this range. So this type of distribution is called a normal distribution, right? So our universe, like most of the phenomena in our universe, they are normally distributed, right? Okay, so for example, if I ask you that in the among the class, that how many of you guys are having the let's say the height of like You guys measure in centimeters or inches? Okay, so now I will ask one question from girls. Okay, so who has the highest, the tallest height? Who is the tallest among you guys? So can you guys, the girls who think that I am the tallest, can send me the height in centimeter or inches? So we will make another example in here. Oh, only girls for now. Okay, let's see who is the tallest. The girls, please send me your heights. Okay, 177. Other girls, some girls send me the heights, 177. Okay, so one girl have 177. Okay, 177. And what else? Who is the shortest girl? Okay, 155. Okay, so let's say how many? 150, let's say 150 and 177. Tell me 152 more, 160 and 150 again, 153, 153 more, 156 and 158 and more. Send me. So we will make kind of a real-time example. Okay. Pali Pali, 153, 164, 159. Two more, 152 and 169. Okay, let's say these are some heights of the girls, right? So let's say which is the lowest. Let's say the lowest one, 150 in here, and 150 is the lowest one. Let me say it is the lowest. Okay, what is the highest? What is the highest? Highest is 177. This is highest. 177 is highest. And what else? And okay, so let's try to calculate the mean. Can anyone calculate the mean of these values? 155. Any one of you do it, Pali Pali. 155, 150, 177. Take the mean of this one. What is the mean? Tell me, what is the mean value? Maybe mean value, maybe it's around 155. Okay, it's 158 point. Okay, one said 157.7. Okay, so let's round off. Let's round off 158. Right? It's like let's round off 158. So now you will see this is your mean. This is mean value. So now you will see that most of the girls, like they are near 158, 156, they are near this value 153, near this range 152, 164, right? So if I make a graph like this one, so this is my 177 and the lowest is 150. Lowest is this one, right? So if I make a graph, so my graph will be like some kind of, most of the students, they will like, let's say, this is the center point of this one. Let me calculate this one. 150 plus 177 divided by 2. Okay, so let's say this is 163. So you will feel that most of the students, they will lie somewhere in this point, in this area. So few students will lie in this area and most of the students, they will lie in this area, right? So this is the distribution among your class. So once you will make a graph, you will see like it is like this thing. Of course, it cannot be exactly same. It cannot be like, but you will see a similar kind of pattern. Okay. So later on, we will make a graph here, and then we will check the heights of the boys, uh, and then we will make a graph of this one. Okay. So let's say, okay. Okay, so this one was the skewness and the normal distribution, symmetrical. Let's say another example, another type. What is another type? Let me draw another line in here and line in here. So, oh, okay, sometimes what happened, our data look like, it is look like this one and then this one, right? So now if I make a line in here, okay, so let me, this point, this point will, this point where most of the data lie, right? Most of the data my lies in this area. So this one will always be mod. And median, maybe median will lie somewhere here and mean will lie somewhere here. Let's say this one is a median, and then mean value. Okay. So in that case, make sure that mod, the rule is is mod is less, and then it comes to median, and then mean. And this is known as positively skew. And similarly, another type is like this one, right? Let's say, so in here, the center line in here. So this is again the point where the most of the your data lies. It will be your mod. And maybe in here you have mean somewhere here and median somewhere here, right? This is median, or this will be mean. So this is known as negative skew, right? This is known as negative skewness. Again, again, you can see like how can we relate it. So for example, in the word, you will feel like, if I talk about the like how can I say, the money, that a person that have a mini bank balance. So most of the people, they lie maybe, let's say mostly are like normal, and then there are very few, there are billionaires, and like one or two there are only trillionaire, right? So this can be this can be relate like this one. Okay, so in other case, if it is opposite, you will see again the negative, like again, short-heighted people, very short-height people, you will see that there are really few, like it's a rare to get like a person less than 4 feet or maybe like this one, right? So mostly will lie in this range, and then there will be some which have like 6 feet or more than 6 feet like this one, right? So we can relate these kind of things. Now, you should understand what is the skew, positive, negative, and the symmetrical skewness. Okay, you guys understand? Okay, so one more concept. We will plot a box plot. Box plot. What is a box plot? Box plot is a diagram which tells you the data distribution, right? So for example, it will look like this one. Let me make it more clear. So okay, the box plot look like this one. It will be somewhere in the center, and then in here, and okay, fine, and then in here like this one, and then it is in here, and then again in here. Okay. So what is a box plot? In this figure is known as box plot. In the box plot, we should know that what these points will tell you. Okay, so this line, it tell you the minimum value. Minimum value in a data set. This point will tell you maximum value in a data set. This point will tell you median, not mean. Make sure it is median, not mean. Median value. Okay, so one more thing. There are one more definition. Okay, so this thing is known as quantiles. We can divide our data into different percentiles. For example, I can divide my this data. This is my 50% of data on the left side, 50% on the right side, right? This is 50% and this 50%. If I divide this one again, make a line in the center here again, and this one again. So this one is 25%. This one is 25%. This one 25%. This one is also 25%. Right? So quantile mean that 25%. So from here to here, this is Q1, first quantile. Then this is from here to here, this is 25% of data. This is Q2, Q3, Q4. So from here to here, 25% of data of your data lies in this range. 25% lie, 25% lie, 25% lie. Okay, in that case. Okay, so let's draw the box plot for this one. Okay, this is the box plot for the positively skewed. Okay, so in here you will see that more portion, where is the, okay. You will see most of the portion of your data set, it lies in this range. Most of the portion in this range on this side, right side of this one, right? And in here, this is small portion in this area. So again, this one will be Q1, Q2, Q3, and Q4, right? So these are four quantiles of the your data set. And if you make this one reverse direction, then you will feel that. Okay. This is there was a way to copy it. Anyways, let me try it. Okay, so there is another one. Let's say this one, and here you go like this one, and here you go like, sorry. And this one, and this one. Okay, now here again you will see that most of your data lies in this range. So most of your data will be in this range, and lower portion, small portion is in here. Okay, so again, this one will be Q1, Q2, Q3, and Q4. These are four quantiles of your data set. Okay, so you guys get it? So each and everything of this thing, we will do it in our studio as well, and later on. So make sure these concepts are clear to everyone for now. Okay, so the next thing is I need to talk about the correlation. What is the correlation? So let me show you the figures first. Okay. To understand the correlation, you should understand first the univariate distribution. First is univariate distribution. What is the distribution, univariate distribution? The distribution that involves only one variable is known as the univariate. So the example is like wages earned by a group of workers, right? It is the univariate wages earned. And then there is another, we call it bivariate distribution. What is bivariate distribution? The distribution that involves two variables are known as bivariate distribution. For example, heights and the weights of a certain group of the person, or the ages of husband and wife at the time of their marriage, like this kind of things. We can correlate the two things. Like earlier, I told you X and Y direction. So it is known as the bivariate. So we can say that involves two variables. Right? And then there is a correlation. What is the correlation? In a bivariate distribution, as I told you, if change in one variable affects the other variable, then we can say that these two variables are correlated, right? So for example, how we can relate, we can make a graph between, let's say, temperature. Let's say make a graph between the temperature and temperature in degrees Celsius, and air air consumption. When the temperature will increase, your air conditioner consumption will also increase, right? So when the temperature is, let's say, 30 degree, you will use more air conditioner. When the temperature is low, you don't need to use the consumption. So there will be a kind of correlation. So if you make a graph, so it will be a line like this one, right? So this is a positive correlation. Sometimes what happens if a graph is like this one? Okay, so in here, one variable is increasing, then the other is decreasing. Then this is the negative. It is increasing, the other is also increasing. In here, one is decreasing, the other is increasing. This is known as negative correlation. Okay, so there are two kinds of correlation. First is the negative correlation, and the other is positive correlation. Okay, so if the increase or decrease results in corresponding increase or decrease in the other, so we can say that there is a direct relation, directly proportional, or it is positively correlated. So, and in the negative mean it is inverse related or indirectly related. So these are the things. If the correlation is like its value ranges from -1 to +1. Okay, so its value ranges from -1 to +1. +1 mean perfectly positively correlated. -1 means perfectly negatively correlated. Okay, and if it is 0, 0 means like they are not correlated. Okay, I hope this thing is clear to everyone. Okay, so there are two kinds of like this correlation. It can be linear, or it could be a non-linear. To measure the correlation, there are different ways to find the correlation. First is scatter plots. Number two is we're gonna do it in R. Okay. Second is Pearson correlation coefficient. Number three is Spearman correlation coefficient. Number four, Mann-Kendall correlation coefficient. Right? So we're gonna talk about one by one. So there are direct methods in R to calculate these values between two different series. So I will just tell you the formulas, and then let's move on to the R Studio, and let me show you the first the okay. Let's see. Can you copy? with text. Can we copy it? Okay, so I will show you in the graph. Okay, so first let's go with the Pearson correlation coefficient. So in Pearson correlation coefficient, it is noted by R, and between two values, it is given by covariance of X and Y divided by standard deviation of X and standard deviation of Y. It is given by this formula. Okay. And the author is Spearman. So let me find about this. The Carl. Okay, so 1 minute. Let me find the other formula. Correlation coefficient of correlation variant frequency. Where is the formula? Okay, so wait, we can do it in the R. So let's move in R and then we will find the formula over there. Anyways, about the Spearman and the Mann candle, it is almost somehow same, but instead of covariance, they divide it with the number of values as well. So let's move on there, and then we can find this one. So just make sure that in all the three things, their values, the maximum value and the minimum value, it ranges from -1 to +1, right? So as I told you, -1 is the purely negative correlation, and +1 is the purely positive correlation. Okay. Okay, I hope this thing is clear to everyone. And what else I have to tell you before we further move to our studio? What else I have to tell you? F sphere. Okay, the Spearman coefficient is given by. Okay, so in Spearman R is given by, it is 1/n in here. It will be just 1/n in here over there, and then covariance of X comma Y divided by sigma X sigma Y, like this one. And I think there will be many formulas over there, but I will prefer you guys go to our studio and then we're gonna do it. Okay, so let me see if we can solve the example. Okay, now students, I hope you guys can see the R screen, right? You guys can see the R Studio screen. Okay, so let's move on in here and try to solve the some things practice. Okay, so let's move on in here. Okay, let's class practice and May 5, 2023. Okay, so we will start from here. Okay, so guys, you already know how to make a plot in R. Okay, so let's have a repeat. So basically, we can make X and Y plot using two vectors. So for example, my X is equals to, let's say my X is equals to 1 to 10, and my Y is equals to 1, sorry, let's say 21 to 30, let's say. Okay, so what if you want to draw a plot between X and Y? What you gonna do? You will say PLO. When you will write the plot, you will get these things. So please, everyone of you, open the R Studio and please follow my tutorial example. Okay, so keep following the things that I am doing here, so you will have a better idea, because it is a lab. So during the lab you have to practice as well, and at any point when you feel your R Studio is not working, let me know. Okay, okay, so for example, if you want to pick a plot between X and Y, what you're gonna do, PLO, it will give you option plot, and click in here, and it will ask you what is in here. You can see it is asking you X comma Y. It is asking you, so you will say X is equals to X, because you gave the name this here. So you can give like A and B. So we will not have confusion. Let's say X is equals to A, Y is equals to B, and it will ask you what type of plot you want. I would say type is equals to L. It should be a line plot. Okay, that's it for now. Run this one, and this one. So I hope you guys can see my screen now, right? You guys can see the screen, the plot between X and Y. Okay, so on the right side here, you can see the X and Y. The A, it shows in here A, and the here B, the values. So what do you think? What is the correlation between these values? Can anyone tell me? What could be it will be a positive or negative? Okay, let's calculate the value later on. Okay, so let me make it more fancy. Okay, so let's say I want to give it a title in here as well. I want to take it. So I would say main, MAIN, is equals to comma A versus B, and run. Okay, okay. So A versus B. This is my title. Okay, again, if you want X label, label the X values, and always make sure whenever you write a text, in R, it should be within the inverted commas. Okay, in X, you will say, let's say values of A, And similarly, you will write YLAB and then put the Y label value of use of B, right? Run it. Do you see? Did you see here that I gave the values in here as well? Okay, so if you want that, I don't like the color, I want a different color. Which color you want? Which color? Any option? Any suggestion? Yellow, blue. Yellow will not be visible. Okay, so we will try all the colors. We will try all colors. Okay, so first student, he said the blue and the yellow. So let's say COL is equals to yellow. Why yellow? Whenever you write the yellow, you will see it will become yellow. Okay, so in here it will be yellow. Like it is not that visible, right? It is not that visible, but line the line thickness, we can increase the line thickness. Let me see the line thickness controls. Okay. Let's say plot. It will tell you XY plot. It will tell you about the line thickness as well. Type main details, line type, lines, smooth. Let me see where is the maybe it will be lines, within the lines, line type, line width, maybe LWD. LWD copy. Control V is equals to 2, let's say line width. Now see, you can see it is getting thicker. Yes, LWD. It is getting thicker. Let's say it's 20. It will be very thicker line. Okay, so you can control it by this way. Or one student said that, sir, I want blue. Okay, let's go with the blue line. So it will be blue, right? One student said that, sir, I want pink. No one tell the pink. Why there was no pink? Okay, there was one student violet color, blue is gone, beige color, green. Let's go with the green first. Green. It's green, right? I want red color in here, and I want time which black was already there. Orange color. O-R-A-A-G, orange color. Okay, this is orange color. Okay, this color, let's say this color. Magenta color and sky blue. Okay, sky blue. So let's play color today. This is sky blue. See, all the color, any color you want, just write it and then, okay, silver. Let's say, I never tried silver, by the way. Let's say silver. No, there is no silver color, but for the silver, maybe you can go with the gray, G-R-U-Y. See, for the silver color, you can go with the gray. It will give you this one. Okay, platinum. You guys, maroon may be there. Maroon will be there. See, maroon is there. You have maroon color, and you have brown. Okay, so let me make it the brown. Okay, see brown. Okay, that's it. That's it. Brown is final. Okay. So there was one more color. Okay, let's try lavender. Let's see. They have this color. Oh, they have this one. This one is also look, but it's very light. And one student said that the beige color, right? One student said, sir, beige color. Where is the violet? Okay, let's go with the violet color first. Okay, copy and then Control V. Okay, so finally finished. Now we will not do the coloring. That's it. That's it. Maybe gold. Let's try gold. Gold. Oh yeah, gold color is there. But the gold color is okay. It look okay. But I would prefer um mm, the black color. Okay, so black color will be more visible. Okay, so now you guys you have line. But for example, if you want, sir, we also want a point in here. So instead of line, you write P and then run it and see these are points. Okay, so in here there is a way in that you can also control the point shape. Let me show you how you can change the point. There was a okay, there was a way to, okay, it is in here. Okay, note that unlike as one to use this one. Okay, PCH. Okay, let's try PCH. PCH is equals to 19. Let's try the plot. Now you see it's different. PCH is point. Maybe let's try it with one. One is like this one. 2 is equals to triangle, right? And 3 is equals to maybe something plus. Okay, so for example, you want that I want line plus I want the point both. So you will say B. You will write it B and then there will be both. Okay, is it clear to everyone? Similarly, we can change the line type as well. Ly line type is equals to 1 maybe. So it says there is no line type. Maybe I have to check. Usually I don't use the base function. Here line type. There must be a line type. LYT, LTY, maybe LTY, maybe LTY. Line type, maybe. Oh yeah, line type. So maybe you can say 3 and let's make it only line and then run it again. So see, this is a dashed line over here, right? So you can say, let's say, what is the 4? You can see this is a different line. Number 5 is a different line. Okay, so okay, so that's about the is equals to okay, let me see. RO is equals to C. Okay, guys. So there is another function in which you can plot multiple things in as one plot. See, in here I put the for MF row. Okay, so I will just comment it. Make make multiple plots. Okay, so 3 by 3 mean 3 rows, 3 column. It will make 3 rows, 3 column. Okay, so you guys can make a for loop. Can you guys make a for loop in which you can try all different lines in here? Can anyone make it? A loop, for loop? Make a for loop so I can have all type of lines in here, like 9 different types of plots. Can you guys do it in R? Let's say who gonna do it first and send me the R code. So let's see who will try first. You have 5 minutes to do so. Okay, so students see here, I made a simple R for loop that for I in, sorry, it will not be here. Okay, so for I in 1 to 9, so it will change, it will run the loop and only change my line type in here because I give it the value of I, right? So let me run it. So in here, this one, and my, now see here. So when I was 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see different colors, different line type. Okay, so you want to try different colors as well. Okay, let's try different colors as well. Control Z. Okay. So call, let's make a new vector named colors and give them, start with the, maybe which color, pink. Okay, one is pink, the second one is red, the third one is maybe gold, and the next one is maybe coral. Okay, okay, next one, what else? Okay, let's try is URE. Okay, and then James, you are good in coloring. Tell me more color, a unique color. 1, 2, 3, 4, 5, or okay. So chocolate. Chocolate is good in eating only. Okay, so let's try this one. Okay, because it's going out, so I will make it 1, 2, 3, 4, 5, and more chocolate. Maybe chocolate color they have. Let me try. Okay, they have chocolate color as well. And then magenta is better. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 3, 4, 5, 6, 7. This one will be my 8, and this one will be my ninth. Ninth will be orange. Orange is okay. Orange. Orange is okay, I guess. O-R-A-G. Orange. Okay, so guys, for example, I want to run my one plot with different colors, right? I want this line be different in every time. So, okay, let me zoom it. We can zoom it. So in here, every time the line was changing, but now I want that my color should change. So what I'm gonna do, I would say for I in 1 to 9, or I can say that length of 1 in simple calls within the call. Okay, or I can say that 1 to length of call. What is the length of color? Length of color is 9. So let's say what is the length of color? It is equals to 9, right? So again, try to understand how I am making a loop. So I am saying 8 for I when I is changing from 1 to the length of call. I can simply put it 9 here as well, but I want to make it more dependent, that maybe if I delete something here, so it automatically change in here as well. Okay, so Control Z. Okay, so I will repeat plot everything, but this I will change where earlier it was changing in line type, right? So I will go with it line type is equals to 1 because it will be a solid line like this one. And what should I do? Maybe I can change this color. So col will be equals to not black, right? It will be equals to COLS because I gave the name cols, COLS, and then in bracket, the square bracket, I gave the I. So for example, if you run call and you open it this one, so you say 1, 2, 3, 4, 5, 6, 7, 8, 9. So my number 1 is pink, number 2 is red, number 3 is gold, then coral, and then azure, and then turkish, and then chocolate, and magenta, and then orange, right? These are my 9 different colors. Okay, one student make this one. Okay, so I will check this one. Meanwhile, let's talk about this for loop as well. Okay, so how I'm gonna do, I will just change the value of I. So what it will do, it will start my code from here. It will read here, reach here, 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 here. And when it comes to call, when it is I is equal to 1, let's say I is equals to, let's say when I is equal to 1, what color it will show me? It will show me pink here. Then if I is equals to 2, it will show me which color? Red, right? So I am going to give it I, and then let's run it. Now see here, these colors are pink, this one is red, this is gold, this one is coral, this is azure, this is not visible even. And then this one is turkish and chocolate, and then this one is magenta, and then the final is orange, like this one. Okay, one student send me 1 to line type value. Okay. Oh, that's great. That's great. Okay, so one student send me okay, Misa, you send me the thing. You give the call is equal to I, and then also you give line type into I as well. So we can also change like the two variables. So for example, if I want here I as well, so I will just give the value of I in here. So now it will change the line type, plus it will change my color as well. So let me run it again. So here you can see my line type is also changing. Okay, is it clear to everyone? So any issue like in the for loop? I really want that everyone learn the for loop, please. Hmm. Is it clear? Okay, let's go on for let's further move on. Okay, so this one was about plot and for loop. Okay, so I will send you like in this one and send it to you guys in here. Hmm? What is this one? Okay. Here. Oh, okay. Okay, now you guys can see the one I made in here. Okay, so let's move on to other things as well. Okay, so now our next thing is we need to find the value, the correlation coefficient. Okay, so it is very simple to find the correlation coefficient. Okay, so the thing is you will simply write COR. When you write it, it will automatically come here, and then you will just click it here. So in here, you can see in here it's showing X value, Y value, and then use everything. What method you need? Pearson, Kendall, or Spearman. Okay, so let's try the finding core A comma B, and let's see method is equals to Pearson. Let's say start from Pearson. Now see its value is 1. You guys can see it, like its value is 1. The correlation coefficient is value is 1, right? Is it clear to everyone? Okay, so you can change in here Spearman. It will also give you value of 1 as well. And finally, you can give the value uh, and the double candle, and then okay, DA double L, I think. Okay, now run, and its value is 1 as well. Okay, so now you can calculate the correlation between two different lines and do different vectors or series, right? So calculate it correlation. Okay, so next is calculate the mean. Calculate the mean, median, and mode. Let's calculate. So if you want to calculate the mean, simply write MEAN mean, and then The mean of what? Mean of, let's say, the value of A. Let's say calculate A, right? It will give you the mean value here. This is 5.5. Okay. So mean, let's say median of A, and then MODE of A. Let's see, mean is 5.5, median is 5.5 as well, and mod. Um, for mod, I think we need to install a package in for the mod. Let's say MOD. Uh, most frequency. There was one package I remember. There was one package. Let me tell you. There was one package I forgot. Let me see the name of the package. It was where? Wait, let me. Hmm, Okay, so I can do it in here. Let's say install package, this one. Let me try install this one, and then okay, now it will be available, and then you write MODE of A. It will tell you. Okay, so because everything is occurring one time, so it gives us the first value. So for example, 1 2 comma 2 comma 2 comma 2 3 4 5. So in that case, what will be the mode there? Okay, mode should be equals to what? Where is the error? Mode C is equals to, okay, frequency. It gives you the frequency. Frequency of this one. That 2 is repeated 5 times. Okay, so this could be used, and also there is one more thing, mean median mode, and what else you need to find? The other thing is you need to find the skewness. Okay, so let's try to find the skewness and the distribution thing. Okay, so let's say I create a vector named VEC vector, and it has like run if like let's say 1000 values between 1 to 100. Let's say this one, run, and then let's plot VEC. Type is equals to point. Let's say plot it. You can see in here run if function. Run if function, it tells you that create 1000 points between 1 to 100. Do you think what will be the correlation in here? Can anyone tell me? What would be the correlation? Any idea? Any idea? Can you calculate the correlation of this vector VEC? Let's say this is vector 1 and this is vector 2. $1,000 points between 3 to 630, let's say. Then this one, and then plot back VEC1, comma VEC2. Do you think these two vectors have correlation? Let's try to find correlation. Core VEC1, comma VEC2 correlation. Any idea? And now you can see the correlation is very poor, very poor. So if we keep running this one, let's say the correlation value will be very poor, right? So in here, sometimes we can make arbitrary points in here, like vector 1, vector 2, plot, and correlation, like this one. We can make the correlation between two different values. Okay, so this one was about the correlation things, and then we can also make the normal distribution. Okay, let's plot the okay distribution. This one, I think this one should be in the correlation section. Control X. Okay, maybe somewhere here. Okay, and then it should be in here. Okay, so students, what do you think? What will be the skewness of this value? What would be the skewness? Okay, wait. Let me first save this value. Let's say this vector is let's say this is vector 3. Okay. So in vector 3, I tell my R Studio that create 30 points, create those 30 points which have mean value of 2. Okay. I am giving this argument to my R Studio that create 30 points such that their mean is 2. Okay. Let's say I create vector 3. What do you think? What will be the mean value in here? Let me let's say calculate vector 3. Do you expect 2? In here you can see it is almost 2, right? So again, I create this one and this one. It is 1.81. Again, okay, wait, let me set the set dot seed is equals to now maybe okay. So now it is almost mean is equals to 2 and standard deviation is equals to 1. Let's say I create a vector such like that. Now it's fine. Okay, so students, every time you create this one R norm, your graph will be different. Okay, so don't need to worry. My graph will be different, your graph will be different because it creates randomly any variables. Okay, so now I create our vector that have 30 points in here. So in here you can see 30 points in here. So it's starting from this to this and this one. Okay. And the density mean it shows you that the values, like how many times, like for example my values ranges from like 0 to 4. In here you will see from 0 to 4, maybe maximum is 4, right? Like this one, maybe in here 0 to 4, right? It gives me a value. So standard deviation, if I increase standard deviation, what do you expect? If I increase the standard deviation, let's say I increase the standard deviation, you feel that this is going broader now, right? If I increase the standard deviation 100, let's say, what will happen? Now you see that this thing is increasing, right? So let's say mean is 1 and standard deviation, I increase the standard deviation. Again, I will run it. I will run it again. Standard deviation. But if I decrease the standard, maybe 0.1, maybe, and the mean, let's say what it's gonna show me. Somehow it's okay, but let me see the, okay. So let's try to find the R number. Okay, so plot instead of density, let's plot, it will be plot. Okay, so now you guys can see this thing like the normal distribution. It will not be that much. From here to here, it is not that much, but when we increase maybe 1000, maybe it will be more. See, now you can see this distribution from the mean, it is getting more bigger, right? So this one. Okay, so density, we make a plot with the density. Density plot mean that the occurrence of a particular number. So again, you will see that the values between 1 to 2, like the 1 to 2 values, it will be more, but the values between -1 to the 5, it will be less, right? So skewness. And now let's say, what do you think? What will be the skewness of this one? Can you think? It will be positive or negative? What do you think? Any idea? Okay, let's say mean of, I would say I should, oh, standard deviation 0. It's perfect normal distribution. Okay, so let's say what is the mean of vector 3? 3. Okay, and what else? Mean and skewness, SKE, skewness of the vector 3. is too close. See? So for the skewness, it could be like this one, minus. It could because it is more data is on the right side, maybe. That's why the skewness is negative, right? Let's make another. The skewness now it is positive, right? Again, I will run it again. Sorry. It is minus because maybe because more is on the left side, and then run it again. It is again minus, minus, plus, minus, like this one. You can find the values like in this way, the skewness. Okay, so we talk about the skewness as well, and what else? Okay, so now we need to draw a bar box plot. Okay, so box plot is easy to draw. I just write the box plot and just make the copy. Okay. Skewness and okay, so let me copy it and should be somewhere here. Should be somewhere here. Okay, and now what was I? Okay, box plot. So how we can make the box plot? Just write. Okay, so let's say I have numbers from 1 to 10. Makes box plot of those numbers. See, skewness is not working, so you can go with the let me can you run now? Can you run this one, the one I sent you? Where is the chat? Chat. Okay, first run this one. Okay, so for skewness, just install this one. Where is no link? I sent you. Oh, okay. So I think I sent only one person. 1 minute. Every person in the main. Just just run this one, okay? In R, and then let me know if skewness is working or not. Okay, great. That's great. So skewness is working for everyone. Oh, that's great. Okay. So now let's go with the box plot. So box plot is very easy to draw. Just write the box plot and the number in this way. So, so you will get the box plot in here, right? So if you want to draw a box plot from the different number, so always make sure whenever you want to generate some random numbers, you can do like RNOR, random numbers, and it will say you how many numbers you want. Let's say I would say 100, and mean should be 0, and the standard deviation should be 1. Okay, so let's say this is my back 4. Okay, and then just copy it, and instead of 1 to 10 I will just run it. Okay, let's run it. So now you can see it keep changing. It depends on how my numbers are created. Okay. One thing I want to clear that this line is not a mean value. Okay, This line is not a mean value. This line tells you that the center of your data set. Okay, this line divides your data into the center. Okay, so from here, this is the minimum value. Let's say in this particular data, if you see this data, you will see around -2 will be the minimum. Let's say, what is the minimum value? MIN. Minimum value is minimum value of the VAC4. What is the minimum value? Let's say it is minus 2.01, right? Somewhere here. And then if I ask a the maximum value, it will of VEC, it should be around 2 point something as well. VEC4 maximum value 2.06, right? And what do you expect? What will be the median? Can anyone calculate the median? Median, median of VAC4. It will be somewhere here, right? It will be like somewhere here. It should be, okay? So for me, it is minus 0.16. It should be from like below this one, right? This is in the minus one. Okay, below 0. Okay, and what else? Okay, so again, let's make another one. Let's make a I want to make a that should be like okay, let's make two graph together and make their plot and density VAC4. Okay, so I would go with this one. I want two graphs. So I want how many? I want 2 rows and 1 column. I want 1 column and 2 rows. Okay. So let's say I will run this one. Okay. Let's see. Let's try to elaborate this thing. So this thing makes sense for you. Maybe we can make it box plot vertical or horizontal. It tells you the horizontal or vertical border color path. Oh yeah, horizontal. Maybe true. Maybe let's say horizontal is equal to. Okay. Now see, let's try to draw in this way. Okay, let's draw here. Now, and okay, let's set the limits as well. So we can define a box plot. Let's try Control X plot in here. Okay, so I want the x limit. I want x limit. I want is equals to c is equals to. No, there will be no x limit. Maybe there will be y limit, or I don't know. Maybe we can control this one. Let's see. Let's try to run this one only. Okay. Or what do you think? Do you guys understand about this thing? How you feel? Like, let's try to investigate this thing. Somehow we realize that this graph almost looks symmetrical, right? Somehow it looks symmetrical, right? So in here you will see that um your from here to here it is a bit less, but in here to here it is more. So you will also feel that in this area there is more points, there are more values. From like center to this point there are more values, but from this point to maybe this point there are not much values, and again in here as well, right? So let's try to make another graph like oh, this is somehow symmetrical, this one is as well symmetrical, and in here as well, see, run it, run it. Okay, so that's how the box plot work. And in box plot, you can also add the colors in similar way. Color is equals to, maybe you can add the red, and then this one, you can say this one, and maybe N O P is equals to true. Okay, it can be like in this way as well, like you can make the notch like structure as well, but I prefer in, well, it should not be, I prefer to draw like this way. Okay, so what else? That's about the box plot. Okay, so what else I wanted to tell you about the things. So now, if you guys have any kind of data, you guys can make the a line plot or box plot or any kind of plot, you can make it. So you guys have any question? How about the for loop? How many of you guys can make the for loop? Okay, let's create a poll and ask about the mm, edit for loop, and then we can edit this one. Okay, so I will make a uh, for loop. So I made a for loop survey. So you have to poll that you can handle it or you cannot handle it. Okay. So I save it and then I will launch it. Okay, guys, there is a thing you can just answer me. So I can understand we can practice it more, or should we spend more time about the for loop or not? Okay. So just give answer quickly. Hmm. Okay. So still many students, 67% cannot handle. Okay, so we can we can practice it more again. Answer quickly. Okay, so I realized that around 75% of the class they cannot understand for loop. Okay, let's practice for loop again. Okay, so first I will show you my whiteboard. So okay, so whiteboard in here, it will go here and it will be here. Okay. So students, everyone please look in the whiteboard. So I hope everyone can see the whiteboard. So let's try to understand what for loops do. Okay. So maybe you guys need more practice, but we will do it again and again until everyone understand what is for loop and how it works. Okay. So for example, um, I have a number of bricks. Let's say I have this brick. It is in here, right? And there is a one person in here that is making this brick, like maybe in a chimney or like this one. Okay, and there is another person who is standing in here. His duty is when he make this brick, he take it there, and maybe he is making a maybe a big pole, maybe somewhere here. They are making like maybe something in here, a wall or a house, and take it here and fix it here. And fix it in here. It keep doing. So for example, this is my eye. Okay, I mean that first brick. When he create the first brick, this guy in here, it will take it and put it in here and then come back in here again. So it means my first loop is completed. So I mean it goes from here, fix it there, come back here. So I is equal to 1 is completed. And then again, this guy in here, he will, he already prepared another brick. So now it is my second brick. First brick was already there. Now this guy take the second brick, go back here again, fix here in here. And then he will keep doing this one, keep doing this one, this one, this one, this one, until maybe his target is 100, until you reach 100 point. When it will be 100, his loop is closed, finished. Now your work is done. And your this thing is fixed. Everything is okay now. You guys got it? What is for loop? Sometimes in algorithm, in mathematics, we have to do a similar thing again and again and again and again. Okay, right? So for example, there is, I can give another thing. So for example, um, I have number of students. There is, I I created one quiz, right? In here, I created a quiz, and I have to check it. I have to mark your quiz like tick 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 tick, right? And then go and to my laptop is somewhere here, my computer, and insert the numbers. Okay, so what I will do, I will check first quiz, enter in here, come back here, do this one, do this one. I will keep doing until everything is done, right? So it is, we call it a for loop. For loop. Okay. So now in R, how for loop will work? Let me erase it and then I will tell you how. It is very easy to understand. Okay, so maybe earlier we made a plot. How we made a plot? We say that plot between x comma y, and let's say I gave the main something like A versus B, right? I gave like this one and comma, and the main thing was color is equals to red. Okay, let's say this was my first plot. When I run this code, then what it did, it made a like a graph. It may give me like A here and B here. It gave me a value in here. That's it, right? But what I want that it will keep doing again and again with different colors. I want this one, right? I want that there, I want blue color, magenta color, orange color, gold, different colors of this particular line. So how I will do? There is one way that I will keep editing this one and editing this one again, and it will be time consuming, it will be tiring for me. Instead of this one, I will make a for loop. Okay, so how I will make for loop? For loop will tell me from here, I will just keep it there, keep it there. Okay, so up and down, just we will change the value up and down. For bracket I is your this number of iterations, number of times you want this loop will work. Okay, so I for I in 1, it will start from 1, right? It will, everything will start in with 1. 1 to how many times? The maximum time, maximum iteration. Let's say 1 to, like earlier we gave the value 9, right? because I have 9 different colors. I define 9 colors. So, and then I will make a bracket in here. Okay, so this is the first line in here. So that's the for loop. That's it. So before running my main code, this was my main code. Before running main code, I give a line for loop. Okay, for I in 1 to 9. So it means if you write 1 comma 9 in R, so it will show you 3, 4, 5, 6, 7, 8, 9. It will show you like this one. Okay, so what I'm saying in here, for I in 1, it means I will be 1, then 2, then 3, then 4, 5, 6, 7, 8, 9. Right? It value will be like this one. Okay, so and then I put a bracket. I have to enclose the my main code within this bracket. So within this bracket, so in the start and at the end, I will put it, I will close it. So I put a loop around my this main code, starting from here and closed it with my brackets. Okay, first up there and the second up there. I closed my main thing in here like this one. This was my main code. In main code, I closed it with 2 brackets and I put a for loop, right? So what it will do now, when you run this code, let's say these are the line numbers. The line number is 1, the line number is 2, line number 3, right? Okay. So what it will do, when you run, it will say, okay, there is a for loop. It will say I in 1 to L, 2, 9. So it will define I is equals to 1. So it will say I is equal to 1. It will go here and then go here, and it will find where is I. Where is I? Can it find I anywhere? Can you see I anywhere in here in the main code? Any one of you can see? Where is I in the main code? In the main code, there is no I yet. I didn't define I yet. Yes, I did not define I yet. So one, I run this code. Whenever I will run this code, it will just run this code because it will not find any I. So for example, let me share you again the R code in here. My share screen and then share screen again. Okay. So I hope you guys can see this my screen as well. Okay, so for example, in here, let me make it a simpler first. Let's start with a simple one, and then we will go with a bit complex one. Okay, this really simple thing first. Okay, so in here, I will just remove everything in here so you will not get confused. I will not put this one. I will not put anything in here, right? I will not put anything in. Okay. So first, what I will do, I will put A and B and then plot. It gave me a plot, this one, right? So it means this is line 576 is my main code, right? This is my main code. And I want my line width is, let's say, 1. My line width is 1. And then I want line width to 2. Okay, let's try it again. It's getting thicker. Let's just run this one. This one, and then let's say I want it 3. It will be more thicker. Then I want maybe 4. it will be getting thicker, and then maybe 5, right? So now it is so time consuming for me. I am keep doing this one again and again and again. What should I do? So now I think it is better that I put a for loop here. So in for loop, what it will do, it will run my this main code that consists of line 576 and 577, like unlimited time. I want 1000 times, it will running 1000 times. It will start running 1000 times. Okay. So for example, now the main point come here. Okay. So I say for for. When I write for, it comes in here. So it automatically creates your this bracket, the first bracket, the second bracket, and the middle bracket. This is the middle bracket and the small bracket. It will automatically create you this one. Now what you have to do, you have to copy this control X within this one inside your for loop. Okay, so you can give a space doesn't matter. Okay, so now you enclosed your main plot into for loop. Okay, so now you have to define I. You have to define the iteration. You have to define its first value and the final value. Okay, so what I have to do, I will go, okay, so I will say I in, what is it, 1 2, let's say 20. For I in 1 to 20, run this one. Okay, so for example, now I come here, there is no I, but this code will still run. It will start from line number 575, and then it will go to 576, run this code, and it will find where is I. Once it will not find I, it doesn't impact on our code, and it will keep running, but there will be no change in my main code, right? So let's say I run this one. Sorry, I will just run full. Okay, so now it run my code 20 times. You can see in here, this is 9 plots, then 9 plots again, and then these 2 plots. It means how many plots I have are 20 plots. So for example, I want to run it maybe 4 times. Okay, so I will just run it again. So now 1 2 3 4. Now my line numbers are not changing. Why my lines number are not changing? Any idea why my lines are not changing? Do you know any guess why my lines are not changing? Yes, I is not defined, and it is not a rule that it should be I. It can be any number. It can be Y, it can be O, it can be any number, right? So for our start thing, mostly we use I. Okay, now I have to define I where there is a change. I want the change in line width, right? I want the change in line width. So I will put it's same. Now my code will define I as 1, and then when it reach in line width, it will give the value to 1, and then close it and run, and then go back and run again it 4 times. Now let me run it. Now see, when I was 1, it plot this one. When I was 2, it plot this one. 3, 4, right? So for example, if I want maybe 20 times, it will run your code 20 times. Okay, so see line thickness. If you will go here, it is getting thinner and thinner, right? This was your first plot. Okay. it is getting thinner and thinner. Is it clear? Like the for loop, it will tell you, you will give instructions to your R code to run my main code several times. Okay, you want to run it several times. Okay, so now now there is one more thing. Let's go a bit complex thing. Let's say we're gonna go with a bit complex thing. Not complex. Let's say I want line width is fine for me, like 3 is fine. The line width size 3 is fine. But I want to change what? I want to change the color. Okay, so what I'm gonna do, I will introduce COL and is equals to, let's say red. Initially start with the red. Okay, so now again, when I will run this code, it will not change the color. That it will be the same plot again. It will draw same plot 20 times only. It will not give any change in your plots, right? So now what you have to do, you have to define different colors in here. How you will define different colors in here? Any idea? You cannot do like color is equal to red, then comma, blue, and then blah blah blah. You can just, no, you cannot do this one. You have to define in here, and then you have to change it. Now what do you think, what should I do? Okay, so what I will do, I will make an other array of colors. I made an array of color, and I will link it with my code. I made an other vector. Okay, so what I am gonna do, it's color. So color is also a sequence, a vector, a list of different colors. So let's say if I run the color, it will give me different colors right in here. Okay, now as I already told you that this is a list of numbers, right? So what will be the first one? If you want to see uh, what is the first color in COLS, how you will see? Can anyone tell me? If you want to see what is the first color in COLS? No, by visual, of course, I can see. But if I want, like, I want to make sure, then it is how I will say COL, sorry, COLS, and this one and one. It will tell me that the what is the first value. It will tell me what is the first value. When I will do this one, it will give me pink color. When I will do the second, it will tell me the second value. When I will do it like 9 value, it will give me the orange one. When it will give it to 10, what it will tell me? Do you know? Any idea? When I put the 10 in here, what it will give me? Error. It will give me error because there is no 10th value. There is nothing, right? So my colors are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 10th color is orange. Now what I am gonna do, I say, okay, now I can only change the I value. I can only change I value, right? So what I will say, I will copy this one. I will say copy, and instead of this color in here, I will just delete it and then copy it. This thing, the call stand, it is actually, sorry, 9. The call stand is actually nothing but orange color, right? So for example, if I run my code without a loop, do you think it will run? If let's say I run it this way, it is giving me orange. Why? Because I defined the color should be in calls vector, and its position should be 9th position, right? So I put this one. But now I want to put it into the for loop, right? I want to put into for loop. So now I say that, okay, if I run this loop, so it will plot 20 times, but it will not change my color until I change it to I. Now I can feel that my for loop, it will work well. Okay, so let's try to run it in here. Okay, so in here, okay, so now you see this was my first plot with the pink color, and then red, and then gold, and then blah blah blah. And you will see this is ninth plot. After ninth plot, what is the value? This is 10. There was any color? There was no color, right? So it keep it like no color in here, right? And the next, it is no color over here, right? But because after 9 my colors were finished. So for example, if you add in one more color, maybe you can say that blue, you will add one more color, and now you will see your 10th one will be the blue, but the 11th one, it will be again empty. Okay, let's run this one again. Okay, so now after this one, this is 9th one, and then that 10th one will be blue, right? So now it, you can just delete it, it's not important. Okay, so you will run again and again. So why I am running is 20 times, it is useless to run 20 times. Why? Because after 10 there will be no color, so I will just do it 10, and then it will run. Okay, and then maybe I can say that 5 cross 5 vector, and then yeah, like this one. Sorry. Oh, this is very small. 5 cross 2. Maybe 5 cross 2 is fine. 10 figures. Is it's so small, right? It's not visible even. Okay, let's go with the 3 by 2, 3 by 3. Let's go with 3 by 3. Okay, it look okay now. So this is the concept of the for